Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at securityweekly.com/Signal Sciences. Detect security threats in minutes before it affects your customers with Datadog's newest security monitoring product. Teams can investigate security threats and malicious activity in real time using 75 plus out-of-the-box detection rules and detailed observability data, metrics, traces, and logs in one integrated platform. See it for yourself by signing up for a free trial and receive a Datadog t-shirt by visiting securityweekly.com/Datadog. By connecting to your code repository, Accurix generates a topology across your full stack to reveal risks so that you can harden your architecture. It also scans code for violations against compliance and security standards to enforce best practices. In addition, Accurix develops threat models using vulnerability feeds, IAM privileges, and other data to predict potential breach paths. Learn how easy it is to get started with Accurix at securityweekly.com/Accurix.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Would you like to have all of your favorite Security Weekly content at your fingertips? Do you want to hear from Sam and Andrea when we have upcoming webcasts and technical trainings? Have a question for one of our illustrious hosts, someone from the Security Weekly team, or wish you could just hang out with the Security Weekly crew and community? Subscribe on your favorite podcast catcher, sign up for our mailing list, or join our Discord server to stay in the loop on all things Security Weekly. Visit securityweekly.com/subscribe. In our October 22nd technical training, we will provide a first look at a new free resource that delivers thousands of remedies as a service to bridge the gap between vulnerabilities found and vulnerabilities fixed. Visit securityweekly.com/webcast to see what we have coming up, or visit securityweekly.com/on-demand to view our previously recorded webcasts. And that brings us to the news of the week. In this one, I do want to dip back a little bit to older news. We talked about this last week, and even 2 weeks ago before that was coming up of the Microsoft was now called the zero login flaw or logon flaw. And it's been staying in the news, mostly because there's been a lot of active exploitation from it. It's a pretty elegant exploit because you basically zero out by choice, you can focus on the admin password for one of your, in your Active Directory and gain access. So pretty consequential. But two of the things I wanted to highlight is that it's pretty interesting as a crypto bug, but also there is another thing that stood out to me is from an AppSec perspective is that these messages were supposed to be signed and sealed when the server receives them. Now the server is resistant, is supposed to be resistant to downgrade attacks, but the server also trusts a client that says, oh, hey, look at this. I'm a legacy server, a legacy client trying to connect. I don't support this newfangled thing you're calling signing and sealed. So please accept this spoofed network logon with an all-zero payload. And don't worry about the fact that I haven't signed. Just please accept. And that's what one of the other critical aspects of this vuln was. And so just there's a couple other things we could point out to, but I just wanted to highlight that as an interesting aspect of, are you versioning your APIs and how are you dealing with essentially legacy APIs that have poor security boundaries or poor security controls?
This is the earlier thought over the weekend when I was rereading this stuff was we've seen a lot of vulnerabilities which have been related to, being able to negotiate down to an older API version which had issues. But at the same time, the pause here as I think about it now, you have to have a level of maturity in your org to be able to say, hey, maybe it's not the best idea just to change our API without versioning it. So there's some sort of gray spot in there where you've recognized that you need to version an API, but you haven't figured out how to make sure the older API doesn't bite you in the butt once you put it out there, once you keep supporting it. And by the way, just to comment on this, this is being actively exploited now. It's hitting honeypots.
Yeah, and it's a great example of just how do you deal with legacy code? Because one of the other things I wanted to highlight is that I think we've quite, and to a degree on purpose, avoided actually talking about the specifics of choosing a programming language or even trying to get into, oh, this programming language is better than another one. Because in this case, it really doesn't matter that this would be written in C or C++ or Rust or Go or PHP for that matter, because fundamentally this was a crypto flaw. And a misuse of AES can be thrown into billions of different modes. I don't know what the actual number was, but this was a pretty weird and obscure mode where they misused the initialization vector. And it doesn't really matter what the implementation language was. It was the implementation of the algorithm was what brought them down. In addition to having legacy support. So I think there's some good lessons here if we are the security team talking to our developers, rather than mandating, are you using an approved language? It's more of, what are you building in that language and what could go wrong? And let's try and figure out what the real issues are there, rather than going overcompensating on the GRC side of things, saying that thou shalt only use these 3 different programming languages and nothing else.
Yeah, and then we saw this with SSL too, right? Back in the Heartbleed attacks, right? It's an implementation of a standard that created the vulnerability. It was language independent. So language is only part of it. I mean, these crypto bugs are just absolutely nuts, right? I mean, that's the worst section on the CSSP exam I did. I still don't fully understand some of this stuff. It's crazy. But I mean, we see weird implementations of certain protocols like cryptography, right, that lead to very interesting vulnerabilities regardless of language in some cases.
And I'm with you there on that particular thing, Matt. Crypto is one of my least favorite areas of InfoSec. You guys can probably notice week after week, anytime Matt brings up like a story and starts talking about crypto in detail, I'll go quiet. I care less. But the reason I'm mentioning it this time is that a sign of a bad design? And when we're looking at newer crypto libraries or newer crypto algorithms which are coming out, should we be looking for simplicity in those? Are they becoming more easier to use and not make those? It's really coming back to previous conversation again. It's a config mismanagement, right? If you're picking a library, or excuse me, an algorithm with a bad implementation, or using an older API, right? These type of things. Should we be looking for security methods which don't have those trapdoors in them, so to speak?
I think that's hard, right? Because we need backwards compatibility. We can't break the internet, right? So these algorithms have to support some level of support going back, even though they're trying to make the algorithms better. So it still makes them complex, which means when you fall back to a previous implementation or a previous a type, that's how these things can potentially get opened up.
Sure.
How do you leapfrog this without breaking everything? I don't see a way to get there.
Well, I wasn't specific. Sorry, I wasn't specifically talking about. Oh, hey, careful! I wasn't specifically talking about supporting backwards compatibility, but thinking forward, if you're working on a new project that doesn't have to talk to another system, so you need a solid crypto. You're going to be smart and not write it yourself. It needs to be something that's going to be around for a while. If you look at between Blowfish or Twofish or AES or a few of the newer guys out there, that's where I'm saying, should you be looking for something which is just, you pick a library that has a good open implementation that has minimal choices and just works? Or that's sort of the way I was thinking of that.
Well, and I think to support that, we can kind of watch this play out in real time with TLS 1.3. Because that's where the designers came in and said, you know what, we're going to throw away pretty much everything, but use AES, specifically use GCM mode, so we can get our authenticating encryption as well, all in one single operation. So we also address a performance issue, which was also noted here, is that this AES mode, the CFB8, was actually a very poor performance. So even if we had engineering hats on, we might have been and not security, we could be choosing something better. But back to my point, before I put myself on a tangent, is that let's watch TLS 1.3, because there we have a new protocol that is pretty much says, here's your cipher, here's your mode, just use this. We're not going to give you all of these other options that led to all the other poor poodle and all the great crime, and I can't remember off the top of my head rattle off any others that TLS 1, 1.0, or 1.1, 1.2 had. But how pervasive is TLS 1.3 now, and how does that impact legacy systems? So as possibly we'll see that long trail of legacy systems that need that interface to be able to talk to TLS 1.3, but hopefully they will, from an evolutionary perspective, die off, and the most fit to the environment will be the simpler, better choices of 1.3 and whatever improvements come in the future.
Now I'm going to have to figure out how many TLS 1.1 and 1.2s are still out there compared to 1.3. That's it. Now I got a research project.
There we go. See, show up for the podcast. You're going to get homework. That also gives us a chance, not in no actual logical segue, other than we need to move on, to talk about Chrome bugs. And one of the things here that I wanted to highlight that was kind of interesting is that a couple high and medium Chrome bugs released. So go ahead and patch. Nothing under active exploitation, I believe. But it was $45,000 worth of 4 different bugs. So two $15,000 bugs, a 10K and a 5K. So it's kind of interesting if we're starting to talk about metrics and quantifying security, there still might be something that I'm curious about in terms of how costly was this patch cycle for Google? And if we go to Microsoft Patch Tuesday, how costly was this patch cycle for them in terms of what was found via a bug bounty and what did it cost them? And you can have that comparison to those 5 or so vulnerabilities that they acknowledge in their bounty program. And they also have a bullet point about 2 high and 1 medium vulnerability found from what they just say is hand wave, internal audits, fuzzing, and other initiatives. So if we talk about investments, maybe there's something there. Just more curious to see if that sounds interesting to anyone on our listeners or Discord, or even my 2 illustrious co-hosts.
David Urseg made some good cash out of that bounty program. Just saying. He had 3 of them.
Indeed. So that can be good. And so stick into those bounty programs and find some high value bounties. In terms of other types of bounties, here is an article about TikTok that was reported by a ZDNet reader to, I believe, the author, Catalin Simpano, that basically was demonstrating you could bypass TikTok's MFA by logging into a particular part of their web interface. Now, there were some good caveats, is that the web interface didn't allow you to then change passwords. But in my mind, this kind of stood out as a great, call it a pre-mortem or a great threat modeling exercise when you're sitting down with your team saying, do you actually have a centralized authentication and authorization mechanism? And is it being universally applied? And is it being applied to all of your endpoints? Because it's, yes, obviously we have the login point where we want to make sure we have our MFA applied. But there's, all these mobile apps, web apps call into a very well-defined in modern day web apps, APIs, and maybe some of those APIs don't have that same level of centralized, unified authentication. And I think that was kind of one of the lessons that I took away here.
What I thought was interesting is when we think about web app and mobile apps, we think about the web app being more feature rich than the mobile app. Here's a scenario where the mobile app actually has more features than the web app, which is interesting. It's kind of flipped its head. So you can see the evolution of how TikTok started as an application. It really started as a mobile application, I think, more than it did a web application. And they haven't fully brought some of the features, capabilities that sits in the mobile app to the web app. That's usually not the scenario. It's usually the other way around. So it's just an interesting way to read this one, is that here, for once, the mobile app actually was a little more sophisticated than the web app.
No, that's a great point. I wonder too. That's the where did the security team forget to shift into the web development process that perhaps they did successfully with the mobile? So talk to all your teams. Maybe that's the takeaway there.
I suspect this was the web team thinking securely, but part of that web team's thought process is absolutely none of our users are ever going to be using a mobile desktop, or excuse me, a desktop browser. It's funny because I was thinking when I saw this going over the notes this morning, someone I follow on Instagram, Ting Testing, it's a VC, I think, who usually in consumer products, they'll go through and sort of, talk for a slide or two about what's going on the consumer side of it and what they're looking at in young startups. But this morning they mentioned in a post the TikTok generation, which sort of threw my head for a little bit. And then we've got Oracle, sort of fake buying these guys, and people are making jokes about, license agreements before you actually look at a TikTok and stuff like that. And it's sort of, I'm wondering from a generational point of view, some of the stuff that we're talking about here, how's that going to change, right? I guess the short sort of, distilling down whatever's going on in John's brain is this going to become more common that the mobile interface is more secure instead of less? Because 5 years ago we probably saw the exact opposite of that.
We'll see.
Yeah, we will see. And speaking of Instagram, that gives us yet another vulnerability that was found again, and this
You're
time
welcome.
By some checkpoint researchers who found an RCE. And again, this is a good write-up. There also wanted to know there was a really good write-up that we linked in the show notes about the zero logon that just gives a really great introduction to the crypto problem. In this case, this is the write-up about the checkpoint researchers who said, well, look, we're looking, Instagram deals with images. Here's a couple of image handling libraries. libjpeg turbo was already heavily fuzzed, so we are going to focus on MozJPEG from the Mozilla Foundation. Now, the primary addition that they made was adding a compression algorithm. And so already that's a great point, because compression algorithms are notable for being historically problematic, because you can get some buffer overruns from them, because you can say, oh, sure, trust me, I compressed only a couple bytes, but it just so happens that it turns into a couple gigs when it decompresses, burst your buffers. And indeed, they did some fuzzing, found a crash, and it was an out of bounds write in a integer in the compression algorithm. So I thought that was really neat, just to watch through again a write-up that says, here's our, not necessarily in the brain of John Kinsella, but in the brain of the checkpoint researchers, what was going on there, saying, well, how are we going to reason through figuring out, spend our time, focusing some tools, fuzzing, and in this case, successfully finding a vulnerability. So I thought it was just a great write-up, which I will also add a small asterisk. Both in this particular checkpoint write-up and the one about zero logon had a can full of kind of silly, simple typos. And that's just sort of a meta commentary that says, for as much as we write code and have implementation errors, it's pretty much the same thing when we're writing prose and have typos or grammar errors. Even the security industry, as we're doing nice write-ups, are going to make mistakes. So just kind of a meta inception aside there in terms of problems cropping up.
Yeah, the people writing this stuff, they need to be using something like VS Code or something that's able to catch those mistakes.
Where's that little red squiggly line that points these out?
Just use Google browser, you're good. So it's in there. Let's go.
It's in there. Let's see, what else is in there? Speaking of other things that are in there, we're going to take quite a different change in tack here, and something that was actually called out in the egregious 11, which is, let's see, they call it EE6, for those of you trying to keep track of all of that acronym soup in terms of from our CSA documents, was called insider threat. And this was an insider threat from Shopify. And here my angle more so is, how could you turn this type of incident for your own security team, your own product security team, into saying there are legitimate reasons that a privileged group of users need access, high-level access into data. And are you building, how are you building this privileged access? And do you have audit controls around it? Do you have logging? Basically, a lot of more detective and corrective controls, because the preventive controls here really boil down into, are you hiring trustworthy people? Or, what are the threats that are going to come out of this? So that was just kind of how I wanted to tie it back to our first segment.
And that's why data security is such an important component of the triad, right? App user data. These users had privileged access to get access to some of that data. It was transactional data that they were trying to steal from some of the merchants. Data is an important part of that triad, and we can't forget about data security, encryption, and getting access to that data. It's something that has to be designed in early. It has to be shifted left also to tie it back all the way to the first segment. So don't forget about data.
But I think speaking of data, they did a pretty good job with this one, Shopify. And so I'm a fan of Shopify. I generally, when buddies that are running e-commerce sites are looking to upgrade, or someone's looking to launch a new site, as I tell people, don't run Kubernetes if you don't have to. I'll usually say, go use Shopify. So a little bit of a fan. But the point here being, as far as I know, there was no actual financial data leaked in this transaction, right? So they were actually encrypting and doing some of the right things. Always room for improvement. So it's interesting to see that and go, okay, now that you've done that, what's the next thing you have to do to sort of, climb up that maturity model, which I keep talking about. I think my biggest problem about this right now is actually not the vulnerability itself, but the headline is showing up that Shopify was compromised. So all those friends of mine who I've been telling to go use Shopify are now going, I don't consider this a huge problem.
No, that's a good point. And to their credit, indeed, this was not just all, a lot of information disclosed, because they apparently, from the write-ups, it sounded like they were applying some least privilege access to showing what data is available to ops agents, essentially. Ops agents do need some access just through the nature of their job, but they don't need to see everything. So that was a good example. And of course, this is on a theme, if we think back to, I'm losing sense of time, a month ago, 2 months ago, to the Twitter hack that was very similar, that ops agents access, internal access was compromised in order to gain access to dashboards that could effectively change email addresses, I believe, to take for account takeover for Twitter accounts. So we will continue to see this. It's more of, what are the principles being applied both on the data that you're exposing in such interfaces, as well as the actions that are being exposed as well, and can you tighten them down as much as possible? And that brings us to the final article, which just last week, Microsoft had their Ignite conference. And mostly the write-up from that I see is that basically everything is coming into Visual Studio. Basically, Visual Studio is the new DevOps. So if we're shifting left, it's more of just shift everything into Visual Studio and bam, everything is magically done, which I'm being slightly facetious, but the joking aside, it does look like there's really good steps to bring basically capabilities into where the developers are and let them make informed decisions.
Yeah, we were talking, I don't know if we talked about it last week or we're talking somewhere else about GitHub Actions, right? And what you're starting to see now is Microsoft really starting to leverage the GitHub acquisition into Visual Studio and other aspects of building applications. I mean, they are trying to create kind of the central place for developers to go to build Microsoft-based apps. Hallelujah. For them, I think this is a great move for them. It allows you, I think it's going to allow organizations to not only develop but deploy applications in Azure. So good for them. However, there's still a pretty big environment that's not Microsoft. This is where GitLab and others have done a really, really good job of bringing capabilities forward. But you've seen a major shift in Microsoft over the past couple years of really embracing aspects of Git, open source, et cetera. And that momentum has continued even through Ignite last week.
Yeah, I mean, we can also joke and say it started off with that infamous Balmer video. So for those in the audience, you can go look it up now. Developers, 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 developers. But clearly, it's paying off. And also, too, Microsoft has been very clear with Azure. Azure DevOps or DevSecOps. I can't remember which term they use, but they're calling that out explicit front and center to saying, here are ways that we are going to enable you to build, deploy, and maintain services in our cloud, but using a lot of fundamental systems that aren't proprietary to Microsoft that actually could conceptually move to any other cloud provider. You just have to figure out which pieces you're bolting into GitHub, GitLab, or what other particular vendors, which just also, as a callback to our first segment, where are those vendors have their integration points? Do they have good, robust APIs, or are they stuck in a more of a legacy world where they don't play nice with others?
Yeah, I mean, they took a playbook right out of Amazon with some of this stuff. Azure Logical Apps workflow platform to build the apps right into Azure. I mean, come on, this is why you're seeing Microsoft survive, right? Remember the days way back when Philippe used to tell us Microsoft's dead in 10 years? You were there at the same time I was when he made that prediction. They made a shift to survive, and this is paying off for them in spades right now.
Indeed, yeah. That shift to survive, both in embracing that developer community as well as making their systems scalable to manage, because by getting away from having to deal with the GUI. So even we talked, I think it was last week, we mentioned PowerShell. Just seeing PowerShell now not only available on Windows systems, but Mac and Linux, as well as Windows being able to run virtualized Linux kernels. So indeed, it's some very interesting directions that they've gone, but I think we have to use interesting to be synonymous with successful in this case as well.
Yeah, I did a quick research project while we were here. I on Shodan TLS, I found 4.7 million devices with TLS certificates. I found 28 with TLS version 1.3. Now that's not scientific in nature. I'm just saying we haven't gotten there on traction on TLS 1.3 yet.
Yeah. No, that is good.
Maybe tomorrow.
Yeah, maybe tomorrow. Yeah, next week we'll have an update on those metrics. I will say though that there was, because we are in a more, the modern age of cloud computing, we do have CDN networks that can potentially make this better. So you could have your hop from the browser to your TLS termination from a Cloudflare or an Akamai, say, automatically, here's your free TLS 1.3. And on the back end, from that termination point to your own services, that's where it may have to go down to 1.1, 1.2 for that matter, because you have legacy systems. So I think that we could have a migration path. Now, obviously, there is perhaps a cost as well as some engineering lift there. But in my mind, trying to be the optimistic person here, I can see that as actually being a pretty favorable and a pretty viable path towards migration rather than just try to retrofit on a case-by-case basis all of your old code.
Yeah, those things are really super handy. It's and also, by the way, wasn't planned, but happy 10th birthday to Cloudflare. They are 10 years old this week. But yeah, if you're able to take a lot of that type of stuff and just sort of strip it off and let hopefully somebody you can trust deal with it, that's at least in my book the way to go. And unless you're in the business of writing security tools or you got a really strong interest in that type of stuff, let the experts deal with it.
Let the experts deal with it. And that's why I brought you two on to help me out with these episodes. So I want to say, once again, thank you to Matt. Thank you to John. Thanks to everyone listening, especially everyone who's been active in the Discord during our live stream. So please do sign up for our mailing list and join our Discord. Thanks once again for joining us. We'll see you again next week on Application Security Weekly.